Alright, now looking at the quadratic, okay, let's look at the context of the problem. It says the graph below shows the height of a ball versus time for one bounce, right? So we're going to bounce the ball. It's going to start out at the height of 0. It's going to go all the way up here, which would represent the maximum height, and then it's going to go back down to the ground. Okay, again, this is going to be your time. Your x-intercept is going to be your time. Sorry, x-axis is going to be your time. So let's look at the value for the domain. Again, the domain is the x-axis, the x values. So it starts at 0, and it ends at 2. So the meaning of this problem, this is the time it took for one bounce. Range starts at 0, goes all the way up to the maximum height, which would be right here at 16. We'll say that's the height of the ball. X-intercepts, we have 2 of them, where it crosses the x-axis. So we have the point at 0, 0, and we have the point at 2, 0. And that would be the time when the ball is on the ground. The y-intercept is right here at 0, 0. Okay, and that would be the initial height. Right, so we're starting from the ground. Ball's bouncing. The intercepts, the zeros are another word for x-intercepts. So the same thing here, 0, 0, and 2, 0. So x equals 0 and x equals 2. And once again, it's the time when the ball hits the ground. Maximum or minimum value, which is the vertex. Okay, in this case, it's going to be a max. Okay, and that's going to be the maximum height of the ball. The vertex is that point, the maximum, which is the point 116. And again, what does that mean? It's the time when the ball is highest. And the axis of symmetry goes through the x value of my vertex. So it's going to be x equals 1. Okay, again, it's going to go through the x value of your vertex, and it's always going to be x equals the x value of your vertex. So the axis of symmetry divides into 2 congruent parts, and so we'll say that's the time when the ball starts to descend.